What's happening, guys? Welcome back to episode 2 of Tutorial Tuesday, where today we're going to be building the F5 armament panel that we designed in episode 1. So if you're new here and you didn't get to watch us design it and that's something that you're interested in, go check it out, then come back, because today we're finishing it off and we're going to have a fully functional replica F5 armament panel ready to use. So to get it done today, we're going to need a laser cut and paint some panels, 3D print and build a case for it, install the wiring, upload the code, and then we're good to go. So let's jump on into the first program called Lightburn, and that's what's going to connect our computer to our laser cutter. Here we are in Lightburn now. We're going to click import on the top left, and we're going to select our first panel. And that's the top plate of the armament panel, which is the larger of the two. Selecting open, it default gives us all black lines. We can just go move that to the top left, where I know I've got a nice piece of acrylic waiting on the laser bed, ready to cut. Zooming in to see what we're doing, the way Lightburn works is it uses color profiles, which has speed and power assigned to it, to tell the laser what to do. Now, before you go and start blindly following my laser profile settings, they may be close, but they also may not be. The reason is 50% power on my laser cutter could very well be different to 50% on yours, especially if we have different power supply units or we have different laser tube strengths. So getting back into Lightburn now, I want to cut this out of 2mm white acrylic, and I know that I've got a preset down on the bottom left here, which is the 01, and that's blue, and that's going to cut the panel at 12mm a second at 50% power. So let's go ahead and select all the shapes that we want to cut. And then to make it easy for us later on, we're also going to add the engraving color. Now you're probably wondering, why on earth don't you just make them all the same color? Because it's the same power settings. You can see them right here. The light green, the dark green, and the purple are all 150 at 14%. Well, the reason for that is it allows me to control where the laser head goes and how much it travels over the piece during the engraving. Now, it's not to speed it up or anything. It is purely that I want to clump all the different sections together. That way, if for some reason there is slight movement from vibration, or just gantry misalignment, it's going to keep the engraving look pretty neat. And we're not going to pick up with our eye that there is slight misalignment. So it does take a little bit more time doing it this way, but it's going to save you having a messy looking engrave and then have to remake the panel. Now that's all done. The next step in the process is to deselect all of the engraving layers, which are the ones by fill with 150/14. That way we're only sending the blue lines to our laser cutter, and then we're going to be good to go. We're going to press send F5 armament 1, which is a pretty reasonable name for us. Actually, let's call it F5 2mm white W. Cool. Then we're going to press OK, and that's now sent to the laser. So the next time I see you, we're going to be back up here at the studio gluing the two panels together. Alrighty, welcome back. We're here at the workstation with our freshly laser cut parts. What you're noticing though is our little jettison panel was painted yellow first. That way I could put a blue masking tape on the top and then cut it out, having a perfectly aligned mask for our caution stripes. To glue these together, we're going to be using a solvent-based cement called Acrybond 105. It's pretty fast setting, super thin, dries clear, and there's nothing better for this job. Now, a quick word of warning, it's pretty toxic. So you're going to need some good chemically resistant gloves and a respirator. So let's get into gluing it. You're not going to hear me with the respirator on, so I'll have a chat to you when we're done. And then we can go and paint it, engrave it. And by that stage, when the paint's drying, we should be able to come back upstairs and our case should be ready to come off the 3D printer. Alright, so we're pretty much done with that. What you would have noticed me do is take my pipette and run a bead of glue around the edges. The reason for that is there might be tiny little cracks, and the super thin glue has a great capillary effect where it just sucks it into the gaps. And when you do it at home, you'll see it actually form and flood all through it. And it acts as a natural filler. So we can take a sanding stick and just lightly go over them and just take away some of the laser cutting striations as well as the glue marks. And if you did get any glue on the front face, don't touch it, just let it dry. You can sand it out. As soon as you start putting fingerprints in there to try to wipe it away, you're gonna mark up your front face. So that's about it. I'm gonna finish sanding these and then we're gonna go downstairs and we're gonna go put some paint on them. Now, just a quick thing that I didn't mention before, if you're following along at home and you're using the Lightburn files that I provided, you will notice that on the back of each diffuser, as well as the back plate, there's a bit of a mask. It comes about 3 mil off, and the reason for that is when we paint this all black, you want the paint to wrap around the panel, locking in all that light. These don't sit flush, they never will. So if you don't have that little lip of black paint on the back, you're gonna get light leaking out the back. So when you do see it, that's what it is. And if you're not using these models at home and you're doing your own just for any panels you're doing, keep that in mind. It'll make your panels look so much nicer and you won't get that pesky light leaking out when you take some photos. Okay, so while the paint's drying, we're going to get onto the case, and we've got our 2 fresh pieces here straight off the printer. All we've got to do with these is take the brim off them, remove the supports, and I'm really impressed with the Neptune 4 Pro's quality, because there's not a lot of tidy up I need to do on this. A little bit of putty once we glue them together, and that's about it. So let's get into cleaning these up, construct it, paint it, and then we should be good to start the wiring. Now, a tool I like to use to deal with elephant's foot, and an elephant's foot is the first layer on a filament 3D print. You can even get it on resin, where it's been squished a bit more than you would like, spreading it out, looking like an elephant's foot. Use a deburring tool for that. You can just run along the edge, take away that extra bit of layer, and you're good to go. Nice, that's about it. So they pretty much done. The only supports we haven't taken out are the supports in the top section where the top hatch will connect to with heat inserts, but we can always drill those out later. Let's see if we can dry fit this to see what the test is like. Bit of brute force, that's what you need with it. That once you snap it together, fits really well. I'm actually really happy with that. It's not firm enough that you can't get away with it without glue, but I think that's really good. So yeah, that's actually quite nice. Okay, so the reason I chose to wait to glue this was I needed to wait for the paint on the back plate to fully dry so I can dry fit it in here before gluing. The reason for that is printing comes with dimensional inaccuracy. You can't avoid it. It's just one of those things. So what we're going to do is dry fit our back plate in here, apply some clamps, and then we can glue it all together. So we're going to let that dry, we're going to finish that up, and then we're going to head downstairs, put a spray putty on it, paint it, and the next time I see you, we're going to start wiring. Alrighty guys, welcome back. We're here day 2 of the F5 arm panel build, and we're in the final stretch. All we've got to do now is install the heat insert so we can mount the top hatch and the front panel, pop our switches onto the back plate, and then we just got to wire it up with Arduino, install some code, and then we're going to be good to go. So let's get the case now. All we've got to do is pop 4 brass M4 heat inserts into the top, and then along the top rails, we're going to pop 12 M3 brass heat inserts. Trick with this is, if you do have one at home, use an old soldering iron. I've got a very cheap Duratec soldering iron that I had from when I first started with electronics. And the reason I use that is so the PLA, if it comes through the heat insert, doesn't mess up my nice soldering tip. Keep a good quality soldering iron for your circuit boards, and then have a junk one that's nice and cheap that you can get from any electronics store for all of this sort of work. Alrighty, let's grab the top hatch and just do a bit of an alignment check. And the reason I do this is because sometimes it's just not going to align properly. They don't thread in, they just kind of push in with heat. So the top row is all looking pretty good. Bottom left, bottom right, I'll readjust and we're good to go. Nope, use the old one. So that's pretty much done. It's pretty quick when you get the hang of it. We're now going to get our back plate ready, and then we're going to put our switches onto it. So You'll notice that your toggle switches come with two nuts. The bottom nut is to height adjust it so you don't have your toggle switch sticking all the way through a thin piece of material. So don't chuck the second nut away. I generally, for having a 3mm backing with 5mm worth of front plate, which is 2mm white, 3mm translucent, if you can get it roughly there on the second thread from the bottom, you're going to be good to go. That should look so good. You'll notice on my back plate, one side's black and then it's grey. The reason I painted black first was you're going to need 3-4 more extra coats of grey to have the same backlight blocking effect as black. So I always do black first and then I paint the colour. You'll notice here on the potentiometer mounting, I've got them put for registration keys, so you can have the potentiometer in any angle. I really wanted to see what the wiring would look like once it was on the panel, so that's why there's 4. So pick whichever one you want to use. There's no right or wrong one. It's just whatever suits the wiring the best. Alright, that's pretty good. The reason I'm leaving the camera missile gun switch by itself is you do need to install the red missile cover before you can put these on. It just fits so perfect as well. It's so nice. Good. There. Jettison panel. Now we get to do is peel off that mask, and we should have some pretty nice yellow caution stripes. Ah, look at that. That is very nice. It actually looks really, really good. Look at that. That's very cool. I'm so happy. Lovely. I've got a tear in my glove. Oh. Let's get the guard, push button guard switches gluing, and then we can put the backline. To glue these on, I'm using a product called Micro Crystal Clear. It's just a super high quality PVA glue, really. Dries clear, good bond, and the reason I use it instead of a CA glue is so if I need to pull them off and change them, it's not locked in. I can snap them off quite easily. Lovely, let's pop that to a side. And we're going to work on the backlighting. So let's get ourselves a piece of strip lighting. This is 5mm, I think it is. 3mm maybe, warm white LED strip lighting, which I'll use to run in the back. That actually fitted surprisingly well. Very good. So what we're going to be doing with the backlighting is, you don't know what power source you're going to be using. This could go to anyone. I don't want them to have an overvoltage situation. So what we're using is just a DC to DC converter or a step-down converter, buck converter. It takes your input voltage from anywhere up to 35 volts and brings it down to a desired voltage, and you can change the little potentiometer on the buck converter. So I'm going to run this in line from input voltage through the buck converter to output voltage, where we're going to put a switch. That way we can turn the backlight on and off as we see fit. Alright, that's done. So I'm just putting a 2.1mm DC jack connector onto here. That way it takes most power plugs. There we go. And alright, so what we're going to do now is just feed all of our cables out through the top, arrange them, and then we're going to plug them into the Arduino. What you're going to notice with my wiring is everything that connects to ground is actually a red wire, and everything that goes to a signal is black. And the reason I do that is I usually make PCBs with pull down resistors. Because I want to make this as simple as possible for you, we're going to be doing it with a pull up resistor that's already built into our Arduino. So the coloring is going to look a bit backwards, but the reason I've still gone with black for this is because I plan to upgrade this to a full functional circuit board using pull down resistors, and then it's going to look perfect. So don't follow my coloring, follow the theory behind what we're doing, and that is connecting pin 2 of each switch to the ground, and then pin 1 and or 3 to the signal on Arduino. I'm actually really excited to finish this because for anyone that knows me and my hobbies, I have an 80% completion rate. I generally will start something, I'll get 80% through, almost to where you could think it's done, and then I'll find another hobby or project to start on. So I'm glad we get to finish this and then send this one off. Lovely. Let's pop this on its back. All right, let's pop these yellow switch battens, they claim to be called, on pylons 1, 7, and 4 to make it look like in-game. And the reason I use pliers to hold the base of the switch lever is you don't want to push the switch into itself. They are pretty tricky to get on, so just use some pliers. Go. Lovely. While it's on its back, let's go and pop in the suction cups. And the reason I put suction cups in last, don't put them first, because you're going to be constantly suction cupping your workpiece to the bench. And there we are. We're done. Other than a couple of screws and spare nuts on the workbench, there's nothing more we can add to this. So that means we have come to the completion of building an F5 armament panel. If you're still watching, I hope you got something out of this. Either the weird wacky way that I think when it comes to color matching wires, or you found something useful. But regardless, I hope you had as much fun as I had building this, and the links are all below. So go across to Cult 3D, download, it's all for free. I want to see you make an F5 arm panel, and if you do, please tag me at a hornet's nest so I can just see it come to life for you as well. So final test with the backlighting. Let's grab our power cable and let's see how it goes connecting to power. That's very cool. I'm really happy with this. The backlighting is perfect. It's exactly how I wanted the yellow paint for the caution stripes. Yeah, I'm super stoked. So I hope you had as much fun as I did making this. If you decide to go ahead and download, all the links are down below. Tag me, because I really want to see your F5 arm panel come to life, and it would just be the coolest thing to know that somebody has followed this tutorial, made it, and wants to share it. So yeah, that's about it for today. I can't wait for episode 3. Got some really cool things coming up in the future. Stay tuned. Thank you for all your support over episode 1. Yeah, I'm incredibly lucky and fortunate that I get to do this and get to share something that I'm passionate about. So I'll see you in the next video. Enjoy the rest of the week. Stay safe. Enjoy your flight sim. I'll see you soon.